why Bitcoin, what is Bitcoin, Bitcoin transactions and how they work, what is a digital signature, what is a full node, and what is Bitcoin mining and how does it work. So I'm going to stop there. First is why Bitcoin. It's digital money, or at least it wants to be. But my reason is because Bitcoin is your money. That's what makes it different from the money that you have in your pocket. And I got some Korean won in my pocket. So how is Bitcoin different from this kind of money, wherever you may be? Okay, so Venezuela. This is current. Okay, 2012 to the present. Here's $1 US, and here is the amount of Venezuelan money that you need to equal $1 US. This is called hyperinflation, and it has a lot of consequences. This is what happens when a government mismanages the economy. So let's get that. So there are three ways that governments raise funds. So they tax, they borrow, which will involve future taxation, inflation, or defaulting on their whatever they borrow, or inflation, and that's where they print more money for themselves to use. And this is actually also a tax on everybody else in the country as well, because when you print more money for yourself, you're devaluing the amount of money that everybody else has, because you're increasing the supply. So the market is going to reflect that eventually. What can you do with hyperinflated money? Well, you can drop it on the street and give people jobs so they can clean it up. You can make wallpaper on your home. This is all Germany, by the way. This is Germany in the 1920s. These are the marks. You can make a kite. In Cyprus, this is more recent. They're protesting the banks because the Cyprus government said, banks are closed, you can't take out your money, you can only take out a certain amount each day. And so somebody holds up a sign that says, beware of dodgy banks. But it's the Bank of Cyprus. So these people are lifting up the gate to try to get into the ATM to get their money. So with Bitcoin, Bitcoin is your money. It's global money. It's created for the people. It's backed by the people. It's not backed by any government. And it's protected by math and cryptography. These are some Bitcoin buzzwords that you might want to know if you want to dig deeper into how Bitcoin works. So decentralized means it has no single point of failure. Secure means it cannot be hacked or has never been hacked in Bitcoin's case. Shared ledger is just a list of who owns how much Bitcoin. A full node, that's just a computer that runs the software. And it checks the entire history of Bitcoin to verify if that is correct. A digital signature, that's just like your regular signature in digital form, where you can prove that you agree with whatever process that you're being asked about. For example, sending money. Yes, I agree. You sign your name. Or Bitcoin mining. This is when computers use their hardware and electricity to earn Bitcoins by putting the transactions in an order and putting them on the blockchain, which is the list of money. So what is Bitcoin? Kind of explained that. Bitcoin is peer-to-peer money. It is decentralized consensus. So in Korea, if we have a computer, and in Germany, if they have a computer, and in USA, and in South Africa, whoever runs the computer, we all agree on the same list of who has how much Bitcoin. Bitcoin is secure, meaning that nobody can copy your money or take it. And Bitcoin is digital money. And if you don't agree with one or all of these, then we can at least agree that this is what Bitcoin wants to be. Okay, so Bitcoin is money. Money tends to have lots of attributes: scarce, portable, divisible, uniform. That means 1 equals 1, so 1 Bitcoin is 1 Bitcoin no matter where you go. It's durable, so it lasts, and it's accepted by places. So Bitcoin is basically just a number on a computer that is running the Bitcoin software located somewhere in the world, And it is connected to a whole bunch of other computers that is running the same software or any compatible software and follows the same rules. And all of these computers will agree on the same information because they all have the same list and they all update it together. So if I spend money, then everybody updates their list that I have spent money. And they try to do that at the same time. Okay, so when I first got into Bitcoin, I had some objections. That doesn't sound safe. Someone's just going to steal my money. It's going to be hacked eventually. Someone's going to change the program and create a bunch of Bitcoins for themselves and try to spend those. But you can't actually do those things. And I'm not alone. I think a lot of people who hear about Bitcoin, they think thoughts like these because we think of computers as being able to be hacked or digital things as copy and paste, you know. That's the kind of attacks you would expect. So hopefully you can understand why you can't do that after this. Bitcoin uses computer hardware, computer programming, and computer networking, which is the advanced technology. It uses modern cryptography to have privacy and security. And it uses game theory, economics, to create incentives for people to not break the system. Bitcoin is a balanced economy. It flips today's money system, and it gives control to the users. So the money system that we use in any specific country where the country prints their money, the government is actually in control of this money through the banking systems or through their printing of the money. The people who own the money don't really have full control over this money, how much it's worth. But in Bitcoin, that's not the case. No government can control Bitcoin. What is a Bitcoin transaction? And here's a note just for the bottom. Transaction is usually abbreviated as a TX, and multiple is TXS. So if you ever see this online, that just means transaction. This is a basic Bitcoin transaction. This is the most basic. This information comes from Andreas Antonopoulos' book. It's free, so if you ever care about that. But basically, you have one input, Alice, and she signs it saying she wants to send money to Bob. So the Bitcoin transaction is basically what it's going to do is it's going to take all the money that Alice wants to send. It's going to send 100% of Alice's money. Part of it is going to go to Bob. So if she has 3 Bitcoins, she wants to send 1 Bitcoin to Bob. So she's going to have one output which sends to 1 Bitcoin to Bob, and then she's going to have another output which is going to send the leftover money back to herself. This is how Bitcoin is programmed, so this is how all the transactions are going to work. Here's another kind. There are lots of inputs, so maybe I have Bitcoin located in lots of different places. And altogether my Bitcoin equals 2 Bitcoins. And I want to send all of my Bitcoins just to one place. So this is what it would look like. All of my different addresses would be put together and it would be sent to one place for me. You can do that, and this is just one single transaction, we call it. And the other one is just the inverse of that, where I have all my Bitcoin into one place, and I want to pay out 4 different places to kind of spread out my money. So I can send it, and I can have it distributed to 4 different places. This is also just a single transaction. What is a digital signature? This is really cool. I love digital signatures. Skipping that. Okay, digital signature uses elliptical curve mathematics and cryptography to prove that only a person who knows some secret key can use it to say that they agree to some message. And a message is usually a transaction in Bitcoin. So I want to send a Bitcoin to Bob over here. Then I will use my digital signature, and only the person who knows my secret can approve of that. So it's extremely secure. Actually, I did want to show this. Let me see if it's just too cool. So here's how it works a little bit. if it doesn't go too slow. If it goes too slow, I'll just skip it. But Bitcoin uses a hash function called SHA-256. It has never been broken, and it is extremely secure. And if you go online and if you type in SHA-256, you just type this in to the internet search engine like Google, you can find a generator where you can play with this hash function and see how it works. It doesn't seem like it's, oh, here it is. Sweet. All right, so for the fun, oh, you can't see that. How come? Now can you see it? All right. So the hash function is going to just, let's call it just like a box that does some magical things, right? You're going to put something into the box, magic's going to happen, and then a new thing is going to come out. So that's, I can't explain. All of it is open source, so if you are, really into mathematics and you can understand how that works, it's just kind of like rinsing and recycling and cutting everything down. But you can basically put in a message. Let's say I want to put in the word cat. Who doesn't like cats? So you put the word cat into the box, and out comes some digits, some string of numbers here, and letters. But this is just basically a giant number. And all of these are going to be different. So if I put in Christopher Palasz, that's my name, loves green grass under the rock. Well, I doubt anybody has ever typed this sentence into the hash function. So that means that you are seeing this number for the first time. I mean, nobody has ever seen this number before. You're the first person, or people. So, how cool is that? And you're always going to get a different result here. If you type in just my name, you'll get a different number. But if you want to repeat, put this back into the box, you're going to get this number again. So super cool stuff. All right, back to this, transactions, signatures. Yeah. All right. So this is the magic. This is the input. This is the output. Okay, a Bitcoin private key. That is a super large number. I mean, stupid large. It's so large. You can't even comprehend how large it is, and you can't even speak the name of that number. Like, it's not a billion, not a trillion, not a quadrillion. It's so large you can't even speak the name. A private key. Private key? Yeah, it should say public there. So this is actually should be the word public. A Bitcoin public key is a point on an elliptical curve that is multiplied by your private key number. And when you multiply it on the elliptical curve, that just means you're kind of bouncing it around that number of times until you land in a new spot. And this is, because your private key is so large, this is done in an incomprehensible number of ways, times, until you get to that new point. So the process kind of looks like this, roughly. But here's the elliptical curve, and all you're doing is you're starting and you're multiplying it around, bouncing it around until you get to a new point. Okay, so what you're going to do to get your signed message with your digital signature is you're going to put in your private key plus your public key plus the message you're signing into the hash function, and you're going to get your signed message. So that means that every transaction that you send with Bitcoin is actually mathematically related to the secret information that you're providing. That's why nobody else can copy this transaction and send your money. And digital signatures are really cool because they're actually more secure than your written signature. If you write your signature, somebody can see it and they can just do their best to copy it. They can do a pretty good job. A digital signature, they cannot do that. And your digital signature actually changes. Do I say that here? Yeah. Every time you create a different message and you sign it, your digital signature looks a little bit different. because of the fact that you put it into the hash function with a new message. Yes. What is the Bitcoin blockchain? Simple. The Bitcoin blockchain is just the ledgers. So, actually, I'll move on with that. Let's see. Okay. So the Bitcoin blockchain is the identical ledgers that you keep on the computers. And the ledgers are filled with groups of transactions that are connected. They're all connected by math. So I'll get into more of that later. But here's one of the blocks, for example. The block information is going to have some number. It's going to have some transactions. And then at the bottom, it's going to have some more information to identify it. And all of this stuff, all of this information can be put into the hash function, and you're going to get some shorter number, fixed number. So here's what the blockchain might look like, for example. A block is here, a block is here, a block is here, and all of them are connected. All of the information in this block put through the hash function, and out comes out the fixed number, and then that number goes into the next block. So all of them are connected. Okay, so here's my little example, Bitcoin versus email. So everybody's familiar with email. It's pretty old right now. When you have an email address, you just got some name, and then you have this part here. When you have a Bitcoin address, you're going to have that number that I showed you already. But you're not going to need this part, because this part just is referring to the central server location of the company that really controls your email. In this case, it's Naver. So somewhere in Korea, I assume Korea, Naver has some computer servers where my information is stored. But with Bitcoin, there is no central server. It's, like I said, it's all the servers that have the Bitcoin ledgers. So you're not going to need this part, just going to need this. And here's an example of what a Bitcoin address might look like, although I should update it because that one is not a sacred address. Okay, so you cannot send Bitcoin to an invalid address, but you can send Bitcoin to the wrong valid address. So for example, this email address belongs to me. This is an invalid email address because you spelled it wrong. So it's not a real email address. Nobody owns that one. It doesn't exist, I think. So for this one, let's see. This one might belong to somebody, but it doesn't belong to me. So if you send an email here, then I will never read it. I'm going to go a little faster because I have lots of information. So the key takeaway here is just that when you're sending Bitcoin, you don't have to worry about sending it to some random number if it's not a Bitcoin address. But you should be careful not to send it to like somebody else's address that you don't want to send them Bitcoin. I'm skipping through, save time. Okay. Bitcoin, like I said, it's public, it's open source. So if you want to check the blockchain, you can download the software and you can verify the blockchain, every single transaction that has ever occurred in the history of Bitcoin since it began running, which was almost 10 years ago. And you can also go online and you can see other people's transactions. So Bitcoin is not really anonymous, it's pseudo-anonymous. That means that if I know your Bitcoin address, I can go online and check how much Bitcoin you have in that address. So, but the problem is that it's private because I don't know what your address is. So, that's actually an important point that we want to improve. But if you go to a website like Bitref here, this is a cool website. If you just search online, like on Twitter, people asking for donations or anywhere, you can copy and paste the Bitcoin address into the box and click check. And it's going to show you when the transaction happened, how much they moved, and how much they have in the address. I did that. This is an actual screenshot. I did that to some random address that I found on Twitter. So you got to be careful if you have lots of Bitcoin or any Bitcoin in your address, not to post that publicly Just so you know, everyone can be able to see that if they want to. So here's a love story, Alice and Bob, it's love and betrayal. So you have Bob loves Alice. He wants to send her a Bitcoin out of his great love for her. Hi Bob, I love you Alice. Please send me a Bitcoin, Bob. Okay. Alice needs to give Bob her Bitcoin address. So what's your address? And she does it. Cool. And this is when you have a wallet, you don't actually need to obviously tell somebody this number. Sometimes you can scan the barcode, or sometimes you can just copy paste this and send it through some message. But wallets are making it easier, so it doesn't look so clunky. So Bob uses his private key, which is a secret, to unlock his wallet and prove that he has the authority to move his Bitcoin. And his private key plus his public address is his signature, plus the message. Anyone who knows the secret key can easily learn the Bitcoin address and they can take the money inside. Because the public address and your secret are mathematically related. So you can actually, if you know the secret address, the secret key that nobody is supposed to know but you, then you can actually steal somebody else's Bitcoin, even if you don't know their public address. Alright, so Bob's going to do this thing. He's going to send the money. So he broadcasts, he pushes send on his phone. And now, officially, the broadcast is made, so the Bitcoin is on the internet. The transaction information is on the internet. Some computer nearby hears his system saying, this is the transaction I want to make. And it checks to see if he has enough Bitcoin to send. And if it's correct, then it says, all right, you're good to go. It checks his digital signature, make sure he has the authority, good to go. And then it passes the information along to the other computers, and Alice receives the Bitcoin. That's the end, or is it? We'll find out later. So what is a full node? Full node is a computer that is online and running Bitcoin, has already checked the entire blockchain history and transactions, and has verified that everything is correct. Why are full nodes important? They allow everybody to see that the ledger on the internet is correct and that their transactions have been verified. So this is actually really deeply important to the Bitcoin community, because this is how everybody who has Bitcoin can know that everything is correct. And you're not trusting anybody. That's why we call Bitcoin a trustless system. And full nodes check to make sure Bitcoin miners are not trying to cheat. More on this later. What is Bitcoin mining and how does it work? Okay, so hopefully I can go through this a little bit quickly and finish up, and hopefully it's understandable. But Bitcoin miner is basically somebody who runs a program on their computer and they do some work with their processor. They actually don't use their computer processor anymore because that is way too slow. They have to buy a specialized computer that is manufactured specifically for the only purpose of running the Bitcoin software. And the computer hardware, yeah, let's see. So what they do is they run the software, and by doing that, they can probably earn some, well, maybe not. They can try to earn some Bitcoin. So they're using electricity, which costs them money, to try to earn Bitcoin. Okay, how does it work? It's a race. So let's just imagine everybody in this room has a Bitcoin miner. Then everybody here is working on a math problem. Let's see. Everybody here is working on a math problem. The first person to find the answer to the math problem gets the reward. Today, that reward is 12.5 Bitcoins. So the first person to solve the math problem will get the reward, and everybody else gets nothing. And then we start the race again. And every 10 minutes, the problem is solved, and somebody gets a reward every 10 minutes. So when I started this presentation, I don't know how many people. How long has it been?
24 minutes and 53 seconds.
Okay, so yeah, good. Thank you. Yeah, so you can kind of assume that maybe 2 people have gotten rewards for searching for Bitcoin during this presentation time. Okay. So yeah, I already explained this part, so I'll just skip through it. Okay, I'm going to get into the details a little bit, but what is the math problem? So slower computers or slower mining equipment, they can sometimes win the race because the race is actually just a guessing game. That's all it is. It's a trial and error. Trial and error. You put a number in, you get a number out. If it's correct, you win. So some computers, if they're really slow, they can only do this slowly. So you can't guess as many times as a fast computer. And that's kind of the basis of how to win. So if one person in here owns 5 Bitcoin miners and everybody else only owns 1, this person is 5 times more likely than any other person to win the race. So here they are guessing. One of them ends up being correct. Every 10 minutes they're correct. Okay, so now here's the more complicated version. Yeah. So this Bitcoin program says, I need a hash function. You know, I talked about that. You put something in. This is the hash function. Something comes out. I need a hash function that has an output that begins with 13 zeros. So if you remember when I put in the information on the website and you got this long number, there were not any zeros at the beginning. But here, this program is asking for 13 zeros to start off. That is really difficult if you're just guessing and checking. So basically, you just put in a number, and then, oops, there's no zeros. Try again. Oops, there's no zeros. Try again. You got 1 zero, congratulations, but you need 12 more, so you're wrong. Try again. Oh, you got 2 zeros. Try again. Okay, and that's how it goes until you find the transaction, the output that you need. And the way they do this is when you put in the information, there's one part of the input that you can keep changing. This is called the nonce. And this is just, you're free to choose what this value is going to be. And the only purpose is to change the output to try to get the desired outcome. So that's the technical explanation. And this process is called proof of work, because you're doing work and you can prove that you completed the work by providing the answer. I'm going to move this. Oh, this is actually kind of cool. I'll just do this one thing. So difficulty adjustment. Every 2 weeks about, Bitcoin's difficulty readjusts so that if people are finding blocks too quickly and they're getting the rewards too quickly, then it will make the problem, the math problem, more difficult. So that, again, it takes about 10 minutes per block. There's one more aspect of mining that's important to mention, and then I'm done. So there's mining pools. So let's say that a big company like Microsoft decides to mine Bitcoin. They got a lot of money. So they can buy whole warehouses and fill them with Bitcoin mining machines, right? So that's kind of a problem for Bitcoin. That means Microsoft is going to be able to control which transactions are going to go into the blockchain, and they're going to win lots of rewards. So what we're going to do is we're going to be like, hey, let's all join together. And we'll put all of our mining machines together, and then when we find the reward, we'll just divide the reward up amongst ourselves. So those are called mining pools. And that's one way for smaller entities to compete with larger entities that are mining Bitcoin. So hacking Bitcoin, this is the tragic story. So poor Bob, because he gave his last Bitcoin to Alice out of love, she dumped him, and she kept the Bitcoin. So Bob's a little upset, and he wants to hack into Alice's wallet, and he wants to undo his transaction. So he has this plan to do that. But all the blocks in the blockchain are linked together. So So unfortunately, Bob's transaction to Alice is sitting here. And after that time, there have been many, many, many more transactions put onto the blockchain. And now here's a new one being added. Bob has to change this one. If he wants to change this one, that means he also has to change this one, and this one, and this one, and this one, and all of these. Because they're all linked together. Information from this block is put into this block to create it. Information from actually all of these blocks is embedded inside of every next block. So that's what he's trying to do. So he tries to change one of these ledgers here. Ha ha ha, this is Bob. He's going to change it. But then all the other ledgers, because everybody has their own copy, they say, hey, that's not going to happen. Because my ledger says the truth and yours is different than mine. So I'm broadcasting that, hey, I don't agree with this change. And everyone else is saying, yeah, me neither. That's not what I have. So unfortunately, they reject Bob's change. Okay, and the more blocks come after Bob's transaction, the more difficult it is to hack. And we call it a confirmation when a new block is added. So if your transaction sits here and more blocks are added on top, we call that one confirmation. If there's 6 blocks on top, then your transaction has 6 confirmations. This would be 5. But anyway. Okay, Bitcoin consensus. I'm going to skip this. I don't really see anything interesting to talk about. And these are the basics of Bitcoin. So I'm finished.